So today I'm here to talk to you about the missing network layer. So at a broad level, this is a sort of a vision of what's happening at the intersection of cryptography and deep learning and distributed systems that is in the process of morphing standard AI technologies into more protocol-like technologies where they end up being a little more distributed. And I think that has a lot of relevance for folks who are in the room. Next up, assume many here are familiar with kind of the AI action plan that also framed decisively AI in the United States from a competitive landscape. And so this has some relevance for that as well. And the reason for that is the scaling laws. I assume many people here are familiar with the scaling laws, but in case you're not, I'll summarize them briefly. It's an observation that as data, compute, and talent increases, it drives increasing amounts of AI capability. So if you wanted to ask how capable is an AI system going to be 5 years from now, one of the best ways to do that would be to speculate on how much growth in data, compute, and talent there's going to be. And a second element of that we're going to talk about today is when you want to predict what's going to happen to AI technology, one really good way to do that is to predict or to observe where is there a bunch of data, compute, or talent that is not being tapped right now. So the big famous example here being a video game industry developed graphics processing units or GPUs. And this eventually became too enticing for the AI industry to stay away from because it allowed for a significant growth in the amount of compute that was available for training and deploying AI systems. So one of the things we want to look for when trying to predict where AI is going to go and try to anticipate what's going to happen next is to observe where is there large amounts of data, compute, or talent that is so far underutilized, if that makes sense. So that'll be very enticing to the AI industry. And this is really going to be the focus of our attention here, which is on the data portion. It might be the case that you're under the perception that AI is trained on huge sums of data, the entire internet. But the surprising bit, at least surprising for me, is that when you look at some of these big web scrapes, for example, Common Crawl being one of the most famous ones that backs the training data sets used for AI, the largest Common Crawl data set is only around 550 terabytes of information. Meanwhile, if you talk to the people who make hard drives and this kind of thing and ask them how much data is out there, they'll tell you it's much closer to 180 zettabytes. Now, for those of you who are not familiar with what a zettabyte is, this is roughly 1 million times more data is out there. Actually, it's closer to 1 billion times more data, but we'll keep it conservative for the moment. And so the real problem, the thing that's holding back AI progress, is that this data remains siloed. So this is the data that isn't available to be crawled or scraped on the public internet and instead exists on all of your devices in here, in all of these buildings sitting next to us, in the cloud infrastructure that is backing lots of the world's biggest corporations and organizations and government agencies. That's where the world's information actually lives. And the vast majority of this is not yet available for training AI systems. And the table that is probably a little too small for you to see right here is basically a listing of the largest AI trained data sets that we know about, was recently published. And the one you'll see at the top is the data set used for Llama 4 Behemoth. So returning back to this question of how does America win? One of those strategies needs to be unlock access or be able to leverage this underutilized resource faster than our competition, if that makes sense. Or how do we de-silo information faster than those that we're competing with? For that, there's really only two options. We can put all the data in one place, or figure out how to train and use AI while data remains in a federated state. So if you're going to use it all together, you got to do one, you got to do the other, or you got to do some combination of the both. Now, I'm not personally a super big fan of putting all the data in one place. I think this has significant drawbacks in terms of, say, personal property or copyright and many of the kind of values that I was born and raised with, and I think many people here probably were. And this brings us to the other alternatives. How can AI be trained and utilized in a way where the data remains in this federated state? And for that, I want to draw you back to the theme for this talk that was mentioned in the title, which is the ARPANET project. I assume, given the nature of what this conference is, most people here will probably have heard of the ARPANET project, given it had such a dramatic impact on the creation of the internet. But for those who aren't aware, the ARPANET project was really two things. So it was started by a man named JCR Licklider, who went to ARPA and pitched this project for time sharing across computer networks. But it did two things. It matured the R&D necessary for this kind of distributed computing. Meaning it was fundamentally pushing R&D forward while also doing a second thing, which was getting actual organizations deployed into a network and triggering these kinds of network effects, if that makes sense. So it was both a R&D test bed that was writing papers and producing what eventually became things like TCP/IP and other protocols integrated with, like www, but also the proving ground for a large group of actual people and actual computing systems to start deploying this together. And it turns out the momentum of those folks starting early had a huge effect. And the reason that I want to stop on this one moment is that when we consider these two strategies, that to winning the R&D race for distributed AI and the deployment race for distributed AI, we need both of these things to happen at the same time. So let me slow down just for one moment and explain why this is such a big deal. ARPANET was launched in around 1968, 1970, but the paper for it was in 1968. At the time, there was a lot of consolidation around Bell Telephone in the United States and around Bell Labs, producing a lot of the great research, all those kinds of things. And yet, somewhat surprisingly, the ARPANET project led to massive public protocols that ultimately were adopted by the whole world in a relatively open and decentralized fashion. This is a little bit surprising, right? The reason this is an exception in the history of the evolution of these types of technologies is that traditionally, it should have been the case that the internet and its low-load protocols were developed in a proprietary manner. They were literally prototyped on top of a large proprietary network. But for some reason, they escaped and became this public protocol that even escaped the United States influence. Because in 1991, the US sought to issue the official protocol standard for the internet and had a little bit of trouble when the rest of the world didn't want to reinstall their systems and change it. And we actually reissued that protocol again that conformed more with the standard internet protocols. Let me summarize that all to say is, today, we're still using 32-bit IP addresses a lot. It is in no one's best interest for us to still be on 32-bit IPs, but it's really sticky once it takes off, if that makes sense. So if you don't remember one other thing from this talk, it's whoever finishes these protocols first will plant those same sticky seeds for how kind of this distributed AI framework ends up working. So if I were to summarize this in kind of two pieces, it is the hunt for 1 million to 1 billion times more data is going to drive AI to become more like a protocol and less like a singular program. And it is vitally important that the United States is the first to do that, if that makes sense, so that we can have the outsized effect on what the values of that system will end up being, just like we did for Internet with ARPANET project. Thank you so much.